Good afternoon and welcome to my YouTube channel. My name is Dr. Emmanuel Nweze, a lecturer at Alex Ekweme Federal University, Ndufalike, Nigeria. Our presentation today is on partial fraction under Elementary Mathematics 1. Resolution of algebraic fractions into partial fractions. The questions in this topic could take any of these four forms. Look at the form for the first question. The second question has x minus 1 squared at the denominator. The third question has x squared plus 4 as a factor at the denominator. And then the fourth question, the degree of the denominator, the polynomial at the denominator, and the polynomial at the numerator, and they are the same. So in that case, we'll look at the note below. What is in the note? We'll examine each question. We ensure that the degree of the polynomial at the denominator is greater than the degree of the polynomial at the numerator. Otherwise, divide the numerator by the denominator first before you resolve the remainder into partial fractions. Also, ensure that each denominator has no factors. If factors exist, then factorize the denominator first before you resolve the expression into partial fractions. Okay, let's look at the first question. The first question, we'll have it in this form. So we will resolve 5x minus 1 over x minus 2 into x plus 1 into a over x minus 2 plus b over x minus x plus 1. This is the nature of the solution we intend to have, but we have to calculate the values of a and b. So in this case, what we do first is to look for the LCM of x minus 2 and x plus 1, and then we'll have it as it is here. In that case, the right hand side and left hand side are equal, and so we can equate the numerators. The right hand side numerator is here, a into x plus 1 plus b into x minus 2 equal to 5x minus 1. 5x minus 1 is coming from the left hand side. How did you get a into x from plus that? If you use x minus 2 to divide the denominator, you are left with x plus 1, and so you multiply it by a, then you have plus sign. If you use x plus 1 to divide the denominator, you are left with x minus 2. You multiply it by b, as we have here. Then, so we now proceed to look at the equation below. Since the left hand side and right hand side are equal here, we can put any number, but we choose to eliminate b by putting s equal to 2 in both sides. And then if you simplify well, you should be able to get a into 2 plus 1 equal to 5 times 2 minus 1. That gives you 3a equal to 9 after simplification. In that case, a equal to 3. Again, we put s equal to minus 1 in both sides in order to eliminate a. In that case, we will have b into minus 1 minus 2 equal to 5 into minus 1 and minus 1. So in that case, if you simplify this very well, you should be able to get b equals to 2. And eventually, that algebraic fraction 5x minus 1 over x minus 2 into x plus 1 becomes 3 over x minus 2 plus 2 over x minus x plus 1. And these two fractions are the partial fractions for this left hand side. That is for that. Let's go to the question number 2. Question number 2 is similar, but there is a square on one of the factors. Once a square appears on one of the factors, you have to repeat that factor at the denominator by the right hand side. Look at how it is done. A over x minus 1 squared plus b over x minus 1 plus c over x plus 2. If this squared had been cubed, I would have cube, square, and then without further power. So now, what do? We still look at the LCM and repeat what we have done above. Then we equate the numerator of the right hand side to the numerator of the left hand side, as we have here. And then we put s equal to 1 as we did before. We should be able to get a equal to 2 if you simplify very well. Then we also put s equal to minus 2. In that case, c is left. If you put it and you calculate very well, you should be able to have 9c equal to 27, so that c equals to 3. And again, we put s equal to 0 for both left and right hand side. In that case, finally you get b equal to 1. Now, the algebraic fraction becomes 2 over x minus 1 squared plus 1 over x minus 1 plus 3 over x plus 2 when you substitute the values of a, b, and c into the main algebraic fraction. Number 3 is the same thing, but there is x squared plus 4, which cannot be factored again. In that case, the right hand side must take this form: ax plus b over x squared plus 4, then plus c over x plus 3. Now, the LCM is the same with the left hand side. You simplify as we have on top, and then we equate the right hand side numerator to that of the left hand side numerator in this form, and then we put s equal to minus 3. In that case, we eliminate a and b straight away, remaining c. So if you put that, you will have this. And now we try to find what we are looking for here. Sorry. Then you simplify 13c equals to minus 13, and then you have c equal to minus 1. Put s equal to 0 again into that equation as we have here clearly. You will now have 3b plus 4c equals to 8, but c is minus 1, so you substitute again, and then you should be able 3b equals to 12, so that b is 4. Then we insert x equal to 1 on both sides carefully and simplify. You should be able to get a equals to 2. Now, that algebraic fraction becomes 2x plus 4 over x squared plus 4 plus minus 1 over x plus 3. Then the last one now is 2x squared minus 4x plus 3 over x squared minus 5x plus 6. You can see that the degree of the polynomial and the denominator and the numerator are the same, so we do long division. If we divide using the denominator, you get 2 plus, there's a remainder. The remainder is 6x minus 9 over that. Then we will now resolve 6x minus 9 over x squared minus 5x plus 6. Fortunately, x squared plus minus 5x plus 6 has two factors, x minus 2, x minus 3. So you take this form, and if you calculate this the way we did in number 1, you should be able to get a equals to minus 3 and b equal to 9. In that case, that our solution becomes 2x squared minus 4x plus 3 over x squared minus 5x plus 6 equal to 2 plus minus 3 over x minus 2 plus 9 over x minus 3. That is it. So simple. Thank you for watching. So those of you who missed the lectures last time should be able to benefit from this video. Thank you. Until we meet again. Bye.